Welcome. Our topic is prime numbers. Prime numbers are numbers that have only two factors, one and itself. In the last lesson, we learned what factors are. We learned that a factor is that number that can divide a particular number without a remainder. So prime numbers are numbers that have only two factors, one and itself. One is not a prime number because it has just one factor, which is 1. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. Each of these numbers has just two factors, one and itself. Factors of 2 are 1 and 2. Factors of 3 are 1 and 3. Factors of 5 are 1 and 5. Factors of 7 are 1 and 7. Factors of 11 are 1 and 11. Factors of 13 are 1 and 13. Factors of 17 are 1 and 17. Factors of 19 are 1 and 19. Factors of 23 are 1 and 23. These numbers have only two factors. There are lots of other numbers that are also prime numbers. Prime factor. A prime factor is a prime number that divides another number without a remainder. A prime factor is a prime number that divides another number without leaving a remainder. What this means is that for a number to be a prime factor, first of all, it must be a prime number, meaning itself, it has just two factors, and also it is able to divide another number without a remainder. The factors of 12 are 1, 2, 3, 4, 6, and 12. But the prime factors are only 2 and 3. This is because of all these factors, only 2 and 3 are prime numbers. 1 is not a prime number. 4 is not a prime number because 4 has 1, 2, and 4 as its factors, which is more than 2 factors. 6 is not a prime number and 12 is not. So out of these factors of 12, only 2 and 3 are prime factors because they are prime numbers. We can express a number as a product of its prime factors. Anytime we hear products in maths, it simply means times. So what we are saying is that we can multiply prime factors. We can express any number as a product of its prime factors. This means that the prime factors can be multiplied by each other to get that number, right? So here are the steps. Number 1, start by dividing the number by the smallest prime number, which is 2, repeatedly until it is no longer divisible. Step 2, move on to the next prime number, 3, then 5 and 7, and so on, repeating the division process. Step 3, continue until the quotient becomes 1. So when we follow these 3 steps, we are going to have a product of the prime factors of that number. Example 1. Express 24 as a product of its prime factors. We will begin with the first prime factor, which is 2. 2 into itself is 1, into 4 is 2. So we have 12. The next prime factor we can use is still 2, because 2 is a factor of 12. So 2 into 12 is 6 times. The next prime factor we will use is still 2. Into 6 is 3. At this point, we can no longer use 2 because 2 is not a factor of 3. We will move to the next prime factor, which is 3. 3 into itself is 1. The moment we have the quotient as 1, we are done with the calculation. So 24 can be written as 2 times 2 times 2 times 3. That is how to express 24 as a product of its prime factors. Example 2. Express 72 as a product of its prime factors. Since 72 is even, we are going to begin with 2. 2 into 7 is 3 times remainder 1. We will put the 1 beside 2. That gives us 12. 2 into 12 is 6. So our new number is 36. Because it is even, we will use 2 again. 2 into 3 is 1. Remember 1. When we place 1 beside 6, we have 16. 2 into 16 is 8. Our new number is 18. Because 18 is even, we will use 2 again. 2 into 18 is 9. Our new number is 9. 9 is not an even number. So we will move to the next prime factor, which is 3. Since 3 can go into 9, we will continue. So 3 into 9 is 3. We will use 3 again. Into itself is 1. So 72 can be written as 2 times 2 times 2 times 3 times 3. Example 3. Express 120 as a product of its prime factors. We will begin with 2 because 120 is an even number. So 2 goes into 1 cannot. We will take 12. 2 into 12 is 6. Into 0 is 0. Our new number is 60. Since it's even, we will use 2 again. 2 into 6 is 3. Into 0 is 0. Our new number is 30. Since it is even, we will use 2 again. 2 into 3 is 1. Remember 1. We will place the 1 beside 0. It gives us 10. 2 into 10 is 5. Our new number is 15. 2 can no longer go. We will use 3. 3 into 15 is 5. We can't use 3 again because 5 cannot divide 3 without a remainder. So we move on to the next prime factor, which is 5. 5 into itself is 1. Our quotient is 1. So 120 can be written as 2 times 2 times 2 times 3 times 5. Right? This is very useful when you want to find square roots of numbers, cube roots of numbers, and carry out other mathematical concepts. So it's important, very important. Please do this class activity on paper, snap and send. Thank you.